In studying kinematics, physicists use quantitative measurement, that is, measurements with a quantity or an amount, such as distance, speed, acceleration, displacement, or velocity. These measurements fall broadly into two categories: vectors, which have both magnitude and direction, such as velocity and displacement, and scalars, such as speed and distance, which have only magnitude. To understand the difference between scalars and vectors, we can use the example of a vehicle driving in a straight line. For this example, our car drives for 5 kilometers or 5,000 meters towards the east. Our distance, defined as the total movement of the vehicle, is 5,000 meters. Our displacement, which is defined as the difference between the final and initial positions, is also 5,000 meters, but in an easterly direction. When measuring our speed and velocity, let's assume that the car took 6 minutes or 360 seconds to cover the 5,000 meters. Our average speed, defined as the distance over the time, is equal to 5,000 meters divided by 360 seconds, which is equal to 13.89 meters per second. Similarly, our average velocity is equal to displacement divided by time. In this case, 5,000 meters divided by 360 seconds is equal to 13.89 meters per second. As this is a vector, we need to say in an easterly direction. In this example, we see very little difference between our scalar values, our distance and speed, compared with our vector values, our displacement and average velocity. This changes, however, when we begin to take into account multiple trips. For this example, let's say our car drives 5,000 meters to the east, as before, and then turns around and drives 3,000 meters to the west. In this situation, our total distance is equal to the sum of the two trips. In this case, 5,000 meters plus 3,000 meters equals 8,000 meters. Our displacement, however, is the difference between the final position of the car and the initial position. In this case, 2,000 meters. If, as before, we assume the car took 6 minutes to drive the initial 5,000 meters, and then a further 3.6 minutes to drive the 3,000 meters, this gives us a total of 9.6 minutes, or 576 seconds for our time. Given this, we can calculate our average speed as 8,000 meters, our distance, divided by 576 seconds, our time, giving 13.89 meters per second. Our average velocity is our displacement, 2,000 meters, divided by our time, giving 3.47 meters per second, a significant difference. As a final example, let's consider that our car drives 5,000 meters to the east, taking 6 minutes, and then turns around and returns to its point of origin, taking a further 6 minutes. In this case, our distance is equal to 5,000 meters plus 5,000 meters equals 10,000 meters. Our average speed is equal to that 10,000 meters divided by 12 minutes, or 720 seconds, given an average speed of 13.89 meters per second. As our vehicle returned to its point of origin, though, our displacement is 0 meters. Consequently, our average velocity is also 0 meters per second. From these examples, you can see the differences between scalars and vectors when studying kinematics.